Okay, here we go. This is our last problem for the year. Look at that. I want us to do this question right here, which was part of last year's Chapter 7 test. We've done a bunch like this. Hopefully, you went through number 1 just a moment ago, and you're like, all right, that's cool, right? I think that the phase plot for number 3 is also very cool. I'm going to go through the beginning of it with you. Oops, sorry. I'm going to go through the beginning of it with you, and hopefully after that you can carry the rest of it, right? So this is some kind of special spring mass system. I'm not a physicist, right? Apparently it is possible. Um, but I want to convert this to a system, which we did some of that back in like February, I think. So you might need some help with that. It was like X1s, I think it was on your test. X2, X3, X4. This one we only need one, so you can do it as a Y. Um, but convert it to a system and then create the phase plot. So I'm gonna help you with that first part. So don't even bother pressing pause yet. Let's see, we'll go past that. We already did that. We also already did that. All right, so um, I will stop right there. Okay, so look, what I can do is let x prime equal y, and then x double prime is going to be y prime. So this right here is the first equation in my system, right? X prime equals y. And the next equation is when I solve for this y prime. So y prime is x double prime. So that means that this is y prime. So the first equation is this guy. The next one is going to be this, right? But then 1, 2, 3 all popped over to the other side. You can see that's what we have right here, right? I've got this guy is positive because it got moved over, and then minus x to the fifth minus 4x. That then goes down to this, right? Which we can pull a negative out of. We get this thing. And then magically factors to x squared minus 4 and x squared minus 1, right? Which are all difference of two squares, which gives me x plus or minus 1, x plus or minus 2. You may say, what are those? Well, those are and then also, look at that, 0, right? So 0 plus or minus 1 plus or minus 2, all of those are going to make this y prime equal to 0. Those are x values. So those are x values for critical points. Then I got to look at the x prime. What would make x prime equal to 0? Oh, y. So what are your critical points? Plus or minus 1, comma 0, and then plus or minus 2, comma 0. And then the last one is 0, comma 0. So after that, right, then you all should be able to do the rest of the work. Remember that when you get imaginary numbers or complex numbers, you can stop and just do do circles or do spirals, sinks, or sources based on whatever saddles or sources or sinks or whatever other things around it give you directional clues. So hit pause, see if you can finish the rest of this with Jacobians and eigenvalues and vectors and phase plots. All right, here we go. Here's the Jacobian. It's nice, it's got some zeros. 0, 0. Okay, 0, 0. I get plus or minus 2i. What's that mean? Circles. 1, 0. I get plus or minus root 6. Notice that is a root 6, which is not an imaginary number. That is real. So it's going to give me it's going to give me a saddle because I got a positive eigenvector and a negative eigenvector. Then when we do the negative one, it works out really nicely. I get the exact same matrix as what I got with the positive one, right? So that's the same thing. And then same goes with the 2, 0, and the negative 2, 0. There's like total symmetry here, right? So that guy gets the same thing, right? Except for this one is imaginary, right? So it's circles, right? So hopefully you got that. If you go ahead before I remove this little post-it, see if you can get that full phase plot together. Here it comes. It's nice and simple. And I love the way it looks. Boom. It's a bunch of circles with some saddles here. And it's totally symmetric. And it just like, I want you to see that we can do these phase plots from these original types of equations, right? That's nonlinear. Um, yeah, so that's it. That's our last problem. Thank you all for everything. You guys all done a great job. I appreciate everything that each of you have done. I appreciate the extra work and um, uh, extra effort you guys have put in doing all this distance learning at home. You all should be proud of yourselves because um, we've done most everything that I would have done otherwise. I skipped maybe a couple things, but you guys have crushed this. You've done a great job. I appreciate you. Juniors, I look forward to next year. Uh, I think we'll have a great time. And seniors, I wish you all the best of luck. I hope you I hope you come back and visit at some point. I'd love to see you guys once it's safe. And that is it. Goodbye. Thank you all.